Modern physics is an effort to understand the underlying processes of the interactions of matter utilizing the tools of science and engineering. It implies that 19th-century descriptions of phenomena are not sufficient to describe nature as observed with modern instruments. It is generally assumed that a consistent description of these observations will incorporate elements of quantum mechanics and relativity. Small velocities and large distances is usually the realm of classical physics. Modern physics often involves extreme conditions. In practice, quantum effects typically involve distances comparable to atoms, while relativistic effects typically involve velocities comparable to the speed of light. Overview. In a literal sense, the term modern physics means up-to-date physics. In this sense, a significant portion of so-called classical physics is modern. However, since roughly 1890, new discoveries have caused significant paradigm shifts. The advent of quantum mechanics, and of Einsteinian relativity. Physics that incorporates elements of either QM or A is said to be modern physics. It is in this latter sense that the term is generally used. Modern physics is often encountered when dealing with extreme conditions. Quantum mechanical effects tend to appear when dealing with lows, while relativistic effects tend to appear when dealing with highs, the middles being classical behavior. For example, when analyzing the behavior of a gas at room temperature, most phenomena will involve the Maxwell-Boltzmann distribution. However, near absolute zero, the Maxwell-Boltzmann distribution fails to account for the observed behavior of the gas, and the Fermi-Dirac or Bose-Einstein distributions have to be used instead. German physicist Albert Einstein, founder of the theory of relativity. German physicist Max Planck, founder of quantum theory. Very often, it is possible to find, or retrieve, the classical behavior from the modern description by analyzing the modern description at low speeds and large distances. When doing so, the result is called the classical limit. Hallmarks of modern physics. These are generally considered to be the topics regarded as the core of the foundation of modern physics. Atomic theory and the evolution of the atomic model in general. Black-body radiation. Frank Hertz experiment. Geiger-Marsden experiment. Gravitational lensing. Michelson-Morley experiment. Photoelectric effect. Quantum thermodynamics. Radioactive phenomena in general. Perihelion precession of Mercury. Stern-Gerlach experiment. Wave-particle duality. Solid-state physics.